So in the previous videos, we talked about transforming your S transfer function into the Z transfer function using two methods. One way is to Z transform, or the other way is to change to state space first, and then you rearrange to become GZ. Correct? That is what we have done. And eventually we get GZ is equals to this thing. Alright, if you don't know what the hell am I talking now, alright, you can watch this thing, Z transform, for using this thing, this method. You can watch using l10v7, okay, which is this one. Alright, if you want to know how do we derive this one using state space, you can also watch these three parts. Okay, it's pretty big, but yeah, these are three parts to use state space. Okay, but nonetheless, in this video, we'll talk about how to change this transfer function, GZ, back into a state space. Okay, it's more challenging now. Alright, if you think about it, if you were to just head back to what we have done left off in the previous video, alright, this is something that we have derived. Alright, same thing, our GZ over here. Correct? So now, so we use the state space, which is what we have derived over in the previous parts. Alright, this is the state space. Alright, and we derive all the way, as you can see, we have derived so many stuff, blah 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 blah, all the way until here. But however, we also can change this back into the state space from where we are, okay, which is this one, but it's in a different method. Alright, we're not using what we have done all along for the matrices. Alright, this is another method that we are going to show you today. Alright, and then for next, I'll just simply paste this transfer function, okay, into our one over here. Okay, but instead of writing my transfer function in this form, I'll write it in this form. Okay, so in other words, the difference is that I'll just rewrite this as t squared over 2 z plus 1 whole thing z minus 1 squared. Okay, they are the same, exactly the same. If you calculate, they should be the same, and they must be the same. However, I'm simply rearranging, alright, in terms of the numerator. Okay, I multiply it in terms of the numerator. Alright, so for state space, or in the digital domain, it is advisable if you were to write your constants of a fraction in terms of the numerator. Okay, this is something that is pretty useful in when you're going to derive your state space. Alright, so this is the first key step. Alright, when you do a certain state space that has a certain fraction, as we can see. Alright, so please be mindful of this. This is the first key thing that you need to know. Alright, so the next one, alright, is that, so apparently now what we're going to do now is to derive the state space. Alright, and our purpose is to prove to you that we can derive back into this dude over here. Okay, so without further ado, we just start, and it will be a very tedious one because there's a lot of things you need to know. But anyway, let's start now. So first, I'll take the yz, or I'll move this thing upwards, So yz times z minus 1 squared, I'll have this thing over here times this thing, I'll have this thing. Okay, just simply rearrangement. Next, I'll just scroll down. Alright, this thing over here, I'll expand, I'll become this. While the rest, I'll leave it the same. I didn't change anything. Okay, so far so good. Now scroll down again. Alright, next, I'll multiply this thing into this thing here and here. All the constants over here are multiplied inside also. Okay, so if I were to multiply all the constants inside them, I'll have this thing as this one, and I'll have this thing as this one. Okay, just pure math derivations. You can just copy down and do yourself, also can. Alright, and next, alright, is now over here now, I'll change from the Z domain into the K domain, the discrete domain. So this portion over here is to change your digital domain into the discrete system now. Okay, so z squared yz, I change it to yk plus 2. Okay, for example, if I have z minus 1, alright, z minus 1 yz, okay, I will have rewrite it as k minus 1. These are the definitions that I'll just in case you forgot, alright, in case you feel that what the hell is going on from here to here. Alright, it's the standard way of us doing things. Alright, this thing tells you the particular yz is a delay by 1 in the digital domain. Okay, so when you change the discrete, it's also delayed by 1. Okay, so if you look in terms of a graphical, this is k, alright, this is k minus 1, this is k minus 2. Okay, so this thing over here is a delay of the k, alright, by 1. So your signal over here is this thing, 1 point, second point, third point. Okay, so if you happen that you forget, so this thing over here will be your yk, this thing over here will be your yk minus 1. Okay, but if you have a minus 2, then you're going to have k minus 2, which is this point over here, your yk minus 2, correct? Next, if I have plus 1, then I have k plus 1. So in this case, I'm talking about something that is a forward, a future system. So I have a k plus 1 over here, you see, k plus 1. Okay, so I have yk plus 1 at this side. This is the discrete point further than k. Alright. Nonetheless, you can also have k plus 2. Alright, so z plus 2 is k plus 2, right? So I have a next point at k plus 2, which is this thing. Okay, and therefore this z square yz, which is this one, can be rewritten as yk plus 2, which is this one. Okay, for further understandings, because I also don't know where I don't know when did I just do it, but anyway, to know more, you can watch these videos. Alright, there's a visualizing graphically Euler's difference method, a bit talking about that, but it's not that good. If you free, you watch. If you don't free, then you just accept these definitions that I've just said, or repeat a few seconds ago and rewatch until you understand what I mean. But anyway, in other words, alright, this you just need to know that z squared yz is yk plus 2. Alright, so if I have a zyz, then I have yk plus 1 because it's z to the power of 1, correct? So the constant minus 2, I'll just bring it down over here. So zyz I change to yk plus 1. Then yz I change to yk. Okay? Because there is no z ma. So if it's yz, simply change to yk, that's all. Equals to, alright, t squared over 2, same thing. z, okay, is a z to the power of 1, right? So it's uk plus 1. Alright, this is u, so I have uk plus 1. That's now is y, so I have yk plus 1. Next, t squared over 2 uz, I'll just write as t squared over 2 uk. Or uz change to uk, that's all. Okay, so I've successfully transformed the digital domain into the discrete domain. Okay, so therefore let's continue. So I'll just simply scroll it down now. Okay, so this next step is another key step. Alright, besides the one from the z domain to this thing over here, the z domain I change to the discrete domain, is one of the key steps also. The next key step is that this minus 2yk plus 1 I'll rewrite as minus yk plus 1 and minus yk plus 1. Okay, the point where you talk about math, purely math intuition, is not just derivations anymore. It's more on working in order to realize that it's minus yk minus yk plus 1. So this thing over here is equals to this. Alright, minus yk plus 1 minus yk plus 1 equals to minus 2yk plus 1. And this is one of the key steps, alright, to dealing with the conversions. Okay, so therefore this thing over here, alright, is this thing. Alright, but this thing is this thing lah. Okay, well, this thing I didn't change, it's still the same. Okay, so the only key step I do is to change this to this only. Okay, next I'll just simply scroll down. Okay, since we have this thing now. Next, I'll just simply divide everything by t, or multiply with everything by 1 over t. So if I were to multiply by 1 over t, alright, I'll have this thing over here, 1 over t. Alright, this thing over here I'll divide by 1 over t also, you see? So over here, yk plus 2 y over t is equals to, or in other words, this thing over here is this thing lah. Alright, hopefully you can see lah. Okay, this thing over here with the divide by t is all these things. Okay, hopefully you can see what I mean. And then t squared over 2, if you divide it by t squared over 2 divided by t can be rewritten as times 1 over t. Same thing. Okay, so t and t squared cancel, we have t over 2. Okay, same thing over here for the t over 2 also. So this step is to rearrange in terms of t, because the purpose of us converting this is to write in terms of this manner. What can you observe? This thing is very similar to your Euler's forward method. Okay? Therefore, it would be advisable if you were to write in terms of the Euler's forward method. Okay, so the next thing is that you may wonder, why didn't I write this thing as over t? Okay, why you may wonder why I didn't write this as that. You can also write this as that, but because I want to prove to you certain stuff. Alright, this thing over here is the last step of this section. Okay, it's the last step of this section. Okay, the next thing coming up is a little bit abstract and things that you have really need to know. Alright, it's in terms of the math, how you rearrange your stuff, which is very chim. Took a long time. Anyway, the next video will explain to you the rest of this section. Alright, how do we acquire equation 1 and equation 2, and what are all this stuff that we are going to talk about. Okay, so the only thing you need to know is that the key understanding is to write the constant on the numerator. Okay, this is the first key understanding in this video. The second key understanding is to observe if it has a 2yk plus 1, you have a 2 constant or maybe some other constants. One way is to break it down. Try to find ways to write in terms of Euler's type of formulas like this. Okay, so this is the two key things that I just want to share with you in this video, or at least is pretty little. There's only two key things you need to know. Alright, so in the next video we'll talk about the rest of the key arrangement, right, or the vital important arrangement that you can finally acquire your state space understanding. Alright, so see you in the next video to continue to derive.